Hey guys, we're going to hit some notes here on midpoints of a segment. Just give a little background here on what midpoint actually means. So when we go through these problems and it discusses the midpoint of a segment, that's just going to be a point that divides our segment into two congruent segments. So I have just a segment here, right, kind of a portion of a line, and if we have some points at the end, let's call them A and B. Somewhere in between, in the middle, is one point, not somewhere, exactly in that place is one point. That is the midpoint. We'll call that M. And if that point M is in fact the midpoint, that means that this part here and this part here are congruent. They're equal lengths, right? So if A, B, right, let's say that whole length is 10 feet long, then that means M is right in the middle, and it creates two segments, AM, that would be 5 feet, and MB, that would be 5 feet. So that's kind of our definition of midpoint and what that means. So we're just going to go ahead and look at a few problems here. I think that's probably the easiest way for us to kind of experiment with these. So segment AB has endpoints at -15 and 4 on a number line. So we're just going to think of a number line, and on one end we have -15, right? Somewhere in here is the 0, and then on this side we have 4. And it's asking me to find the midpoint, right? Maybe I shouldn't put the 0 on there, it's kind of confusing. But we have a number line here, -15 to 4, and we want to know what is the midpoint. So if we had a ruler or something, we could measure it, but I think what we need to think of is how long is this unit total, right? If this is -15 and it goes to 4, like I said, somewhere in there is the 0. There's 15 and 4, the whole length is 19 units long. So the point in the middle is going to be equidistant from each side. So that means half of 19, this half of the segment is going to be half of 19. So that would be 9.5. And this half would be 9.5. So that means to get from there to there, we have to add 9.5. Or to get from there, from 4 to the midpoint, we have to subtract 9.5, and they should end up at the same place. So if I do that, I'll see that I actually end up at -5.5 as my midpoint. So that seems like, you know, kind of counterintuitive to what we normally do with equations and stuff, trying to figure it out, right? Well, luckily for us, there is an equation. If I want to know what the midpoint is between those 2 points, it's right in the middle. If I have 2 numbers and I want to know what's in the middle, I take the average. And so the way we take the average is we add them up, then we divide by how many. So if I want to know what's in the middle of 15 and -15 and 4, I'm going to add them up. So I can add them up and divide by 2, because there's 2 of them. That'll tell me what's in the middle. So if I add those up, I get -11. And then when I divide by 2, I'll see that the midpoint M is at -5.5. So I wanted to just kind of show you how we got there. But then really what's going to be our best asset moving forward is to use an equation like this over here. We don't want to have to think about how far apart they are and then add and subtract from the 2 ends and see where we end up. We want to use an equation because it's going to make our life a lot easier. Okay, so most of the time when we do problems, we're not going to be on a number line or working just horizontally or vertically. We're going to end up with things that are going kind of in a diagonal slanted direction, right? Segments and lines that have some slope that's not 0 or straight up and down undefined. So AB has endpoints 5, -3. Let's change our colors here. So 5, -3, so 1, 2, 3, 4, 5, and down 3. All right, that's point A. I'm just going to put the coordinates. That was 5, -3. and the other point, I guess, is B. Didn't really say, but that's A, that's B. Negative 1, 5. So negative 1, 1, 2, 3, 4, 5. So we have a segment there. Let's see if I can connect them. And it's asking me to find the point M that's in the middle. So somewhere in this area, there's going to be a point that's exactly in the middle. So we want to figure out what that is. What our best method is going, well, let's look at doing it graphically first. Let's do it graphically. So I know that this point that I want to find in the middle is going to have an X and a Y coordinate. So I'm actually going to find out how far apart if I draw a rectangle around that. I can actually count how long each side of the rectangle is and take half of that and it'll tell me like kind of where the middle is. So if I go here 1, 2, 3, 4, 5, 6, right? This side right here on the bottom or the top is going to be 6. So I know 1, 2, 3 is in the middle. And I count how long the side is here vertically, and it's 1, 2, 3, 4, 5, 6, 7, 8 units. So I know 1, 2, 3, 4 is going to be in the middle. And if I see where these two things come together, that's going to tell me where the midpoint is. Right? So it's like half averaging out the x's and averaging out the y's. So my midpoint right here is, that's 1, 2, 1, 2, 1, I think, right? Over 2, up 1. Yep. So that's my midpoint. So we can do it graphically. And if we do problems on Delta Math, there's a series of these problems where you will draw the rectangle around. You'll find what's kind of halfway on the bottom, halfway on the side of the rectangle, and you'll see where they merge here to find the midpoint in the middle. All right, again, doing things graphically is nice, but it's not always going to be the most convenient way to do things. I like to start that way so you can see what we're dealing with, but it's probably not how we want to solve all of our problems. Just like when we were doing systems of equations, you know, we showed you how to graph two lines and see where they cross, that's the solution. But that wasn't how we wanted to solve every problem. We didn't want to graph them and see where they cross because it's not always convenient or accurate. Same thing here, right? I want to show you how you find the midpoint graphically, but that's not going to be what we really want to do. We want to use a formula, right? So it's not always going to be convenient to plot the points. For example, if the numbers are really big, maybe they don't fit on the graph. If you have numbers that are like 57 and 21 and your graph only goes up to 5, like this one here, you're not going to be able to plot those points. So we need to have some other method. That method for us is going to be using the midpoint formula. So the midpoint formula tells us that the coordinate of the midpoint, when the endpoints are A and B, is the following, right? So this whole kind of, this whole thing right here is considered our midpoint formula. What this is really telling us is to find the coordinates of the midpoint, you're going to do exactly like what we did up here, right? Where we wanted to find the coordinates of this segment, the midpoint of this segment in problem A, right? What did we actually do? Well, we added them together and then we divided by 2. We're going to do the same thing, except when the segment is not vertical or horizontal, we're going to have to do that twice, once in the X direction and once in the Y direction. So we'll kind of look at an example. I think you'll see it's really not too hard. So MN has M points at -3, 8. Right, so there's one of our points, and the other endpoint N is at 5, 4. So it doesn't matter which one you call first and second. This M came first, so we'll call this the first point, and we'll call this the second point. And that means this right here, -3, is going to be x1, and the 8 is y1. It's the x coordinate of the first point. 8 is the y coordinate of the first point. And here 5 is the x coordinate of the second point, and 4 is the y coordinate of the second point. So I'm just labeling my points, and now we're just going to use them in our formula up there. Really all we're going to do is we're going to take the two x's and we're going to add them up and divide by 2. Right? We're going to average them out. We're going to see what's the average x. If those are the two n's, what's in the middle? And then we're going to do the same thing with the y. We're going to take the 8 and the 4, and we're going to add them up and divide by 2. So my midpoint right? The x coordinate of the midpoint. So x sub m, we just use that subnote there to kind of label it, right? So x sub m, the x coordinate of the midpoint, I'm going to add up the x's, so -3 and 5, and divide by 2. And if I do that, 5 and -3 is 2, 2 divided by 2, right? So that's 2 over 2 equals 1. And the y coordinate of the midpoint, I'm going to add up the y's. So 8 plus 4 and divide by 2. Eight and 4 is 12, divided by 2 is 6. So my midpoint would have a coordinate of 1, 6. That would be my answer right there. So not too bad, right? All I need to do when I have two endpoints and ask for the midpoint is average out the x's, average out the y's, and it'll tell me what's in the middle. All right, so those are kind of the main problems that we have to be able to do for midpoint, using midpoint formula especially. I'm not sure, normally, in a normal school year situation, we would, continue on to have you find one of the endpoints if you know the other endpoint and the midpoint. So I'm going to do one of those examples. I'm not sure if these are going to come up given this distance learning mode that we're in here and how we'll be looking at some of these things online versus in person, but I want to show you how to do this just in case it comes up and because it's good to know. So here it tells me the midpoint of DG is point M, so -1, 5. One of the endpoints is D, 1, 4. Find the coordinates of the other endpoint, G. So I'm not going to graph this whole thing, but just to kind of quickly, we have an endpoint at 1, 4. So 1, 4. So we have one endpoint there. The midpoint is at -1, 5. So -1, 5. So it's actually going to be up there. So if the orange dot's one of the endpoints and the green dot is the midpoint, then the other end is going to be over here somewhere, right? And we don't know exactly where that is. That's what we're trying to find out, right? This is point D. This is point M. And the one I'm not sure about yet is point G. So I have to find where G is. So we're going to use the same formula, except our variable is going to be in a different spot. The thing we don't know is different. So we know that, let's just change colors here, that the x coordinate of my midpoint, I add up the x's for the two ends and I divide by 2. Well, before we knew x1 and x2, the two endpoints. So we plugged those in and it worked out pretty good. But right now, I know, don't know the two endpoints. I know one of the endpoints in the middle. So I'm going to try and color coordinate this here. So the midpoint was green. So I know that the midpoint x coordinate is -1. So I'm going to replace that with -1. X sub 1, I know one of the endpoints, right? The orange one, D, I know it has an x coordinate of 1. And x sub 2, that's what I don't know, right? I don't know what x sub 2 is. I don't know what these two are over here, x2 and y2. So I'm going to plug in the things I know, and I can see there's like one thing missing. I don't have a lot of room on this, but I see there's only one thing missing, x sub 2. So I can go ahead and solve this equation for x sub 2. So this would require me to multiply this side by 2 to eliminate the fraction, and I have to do the same thing over here. So I have negative 2 equals 1 plus x sub 2. And then to get the x sub 2 all by itself, I have to subtract like that there, so there's a little bit more room. To get the x sub 2 all by itself, I have to subtract away 1. So x sub 2 is negative 3. So I know that the x coordinate at point G is negative 3. And I can do the same thing with the y. So the y coordinate of the midpoint, I would take the two endpoint y's and divide by 2. The y coordinate of the midpoint is 5. The y coordinate of the first endpoint I know is 4. I don't know what the second the y2 is, but I can solve for it because it's the only thing missing. So I'm going to multiply this by 2, do the same over there, and I get 10 equals 4 plus y2. So subtract 4 from both sides, and the y2 has to equal 6. So I know x2 and I know y2. So I know that endpoint G, the coordinates are negative 3, 6. Right? And I can see that kind of looks like where that would be over there. We know it's at least in the right area. So if I got something like negative 3, negative 6, which would be, down here, I know that something went wrong with the sign or whatever. So this last example, I'm not sure if that's something that you're going to need given the current circumstances, but I wanted to show you just in case. We definitely need to be able to use the midpoint formula to find the midpoint between two coordinates on the coordinate plane, like number 4. So that's definitely one we need to be able to do.